We present Efficient Learning of Object Placement with Intra-Category Transfer. Sample-efficient learning from demonstration remains a challenging issue in robotic imitation learning. While humans can learn a new simple task with a handful of training sessions, this is not yet possible for robots. In this work, we present an approach for learning 60 object placements through relative poses from no more than 5 demonstrations. Our approach enables transferring learned models of object poses to other object instances of the same category. In addition, we propose a technique for optimizing trained models and reducing the influence of distractors. We demonstrate our approach in simulation and on a real robot, the performance of which is evaluated by humans. We demonstrate a table sitting arrangement to our system using 4 demonstrations and 1 set of objects. These objects are canonical instances of their respective classes. Our approach can reproduce their demonstrated arrangements with these objects. As our approach is based on relative object poses, it works equally well independent of objects' locations or orientations. After moving the plate, we rerun the inference to demonstrate this robustness. Note that this time the arrangement overall assumes a different orientation due to the rotational invariance of the plate, yet the relative arrangement in this orientation remains consistent. Using the same model, the approach is also able to reproduce the arrangement with other object instances. Here we present the robot with toy cutlery. Despite being much smaller, the approach still infers the poses of the objects correctly. This is enabled by a mapping function, which is used to transfer the inferences performed on the canonical instances to the given object instances. The second scenario we deploy our approach in is a more confined tray setting scenario with a larger number of objects. To evaluate our approach's real-world performance, we survey 111 people for ratings of 15 table setting and 15 tray setting arrangements. 5 images of each set are arrangements produced by humans. By comparison, we find our approach to achieve 73.3% and 62.2% of human performance in these tasks. We presented an approach for few-shot learning of 60 object placement poses with intra-categorical transfer. We deployed this approach in various simulated scenarios and on a real robot in a table setting scenario. In the real-world evaluation, our approach scores 73.3% of human performance for table setting. Going forward, we would like to address multimodal arrangements and would like to investigate semantically richer category maps. We refer you to our full paper for a complete description of our method and experiments. Thank you for your attention.